In this video, I am going to demonstrate the problem-solving process for average velocity type problems. So I'll draw in this example, I'll draw a car traveling on straight level ground here, and it's going to be accelerating. So here's the car at some initial point on the road, and here's the car at some other point down the road. Okay, here's the ground. What I'll also give you here in this example is the car's position versus time graph. So I'll draw a set of axes here. So this is the position, x, in meters, and time in seconds. Time is in seconds with our square brackets, okay? And this is a car that's going to accelerate, so the position versus time graph is going to be quadratic. And I'll give you some values here at different 1 second intervals. So 1 second, 2 seconds, 3 seconds, and 4 seconds. And 1 second, we're going to say that it's actually just 1 meter. It's traveled in the road 1 meter. At 2 seconds, we're going to say it's traveled 12 meters. At 3 seconds, we're going to say that it's 27. And then at 4 seconds, way over here, we're going to say that's 48. So the first observation is that you can see that the distances are getting larger as you go along here because it's accelerating. And what we want to find is we want to find the average velocity from 1 to 4 seconds. So from 1 to 4 seconds over here. All right. Okay, the first step is to list the equation. So the equation for average velocity is V bar, the bar means average, is equal to delta x over delta t. Okay, and the delta is the Greek letter for, the triangle is a Greek letter for delta, D-E-L-T-A. And what it means is change, the change in. It means the change. And really what it means is, in terms of the equation, is the final x position minus the initial. It's always final minus initial. And time final minus time initial. It's always final minus initial. So time there, initial. All right. For the homework, you just have to write down this one. Okay. That's what we need to see. Step 2 is to list the variables. So I'm going to list each of the variables in order here. So there's the V bar, which we're trying to find. There's the delta x. And there's the delta t. So the delta, the average velocity, we don't know. We're trying to find that. Okay. So I'll leave that as a box. That's my unknown. And I know that the unit of velocity is meters per second, so I'll write that in. Okay. Now, for the delta x, here are my 2 points. There's point 1 right there, and there's other point right here at 4 seconds. So what I want is the final minus initial. So the final position is 48, and the initial position's 1. So I have 48 minus 1, and the time is 4 minus 1. And this is going to be in meters, and this is going to be in seconds. Okay. The delta x and delta v. So I have that there. Step 3 is to solve. So the solve part is to actually plug the numbers in. So my average velocity is equal to 48 minus 1 is 47 divided by 3 is equal to, and if you get your calculator out, figure this out here, 47 divided by 3 is 15.66 repeating, so we'll say 15.67 meters per second. So 2 decimal places is usually fine for this class. bracket my units, okay? There you go. And then your final answer, you can say V bar is equal to 15.67 meters per second. And then box the final answer right there like this, okay? So this is the average velocity, okay? That's the final answer. Now, what is it physically on this graph? Well, delta x over delta t, if you look at this, is delta x is the rise, delta t is the run, so it's actually the slope. It's actually the slope of the line that goes through, if I can draw this right here, slope of that line that goes right through those data points, okay? So that's the average velocity. If I were to draw the slope over here somewhere, it would be a little bit not as steep. If I draw it over here, it would be steeper. The average is the one that goes both through both those points, so it's the slope of the line that goes through the 2 points. So for average velocity type problems or any problem, you start off with a given, you have a find. The equation for average velocity is delta x over delta t. We list the variables for that, each of those terms there. And then the solve part is mathematics. We plug in the numbers, and I got 15.67 here, and then we box our final answer. So this is an example of a problem involving average velocity type calculation.